Hi, I'm Tally Motes, and today I will be discussing Lab 1 of Physics 2212, titled Excess Charge on an Ordinary Object. Different objects made with different materials can acquire an excess charge or become charge deficient when they are touched by other objects, pulled apart from other objects, or when they are rubbed on other objects. In this lab, I prepared two pieces of charged plastic tape and observed their interactions in order to determine if they had an excess charge or were charge deficient. I then calculated what the magnitude of this charge was. Different physics principles were used throughout this lab, the first of which being Newton's second law. I will dive further into this concept in the following slides, but for now it is important to note that once this setup was complete, the floating tape's momentum was zero, so I knew that the net force was also going to be equal to zero. I also used concepts of electric field, gravitational field, and electric force. I looked mainly at the interaction of the electric field and the gravitational field on the pieces of tape. Lastly, I used the knowledge that like charges repel and opposite charges attract. At the end of this experiment, I got that the charge of each tape had a magnitude of 8.3 times 10 to the negative ninth coulombs. The total number of electrons on one piece of tape was 5.2 times 10 to the 10th, and that the ratio of atoms to electrons was 2.17 times 10 to the negative 7. I also got that the tape was electron deficient, or that it had a positive charge. I knew this because the charged tape was attracted to a plastic pin that I created a negative charge on by rubbing on my shirt. Opposite charges attract, so I knew the tape must have an overall positive charge. If you look at the image on the right, you can see the setup for the experiment. I prepared two pieces of charged tape. One piece of tape, which I will address as the floating tape, was secured to stack books on either end. Another piece of charged tape was prepared and brought to the underside of the floating tape. The two pieces of tape repelled one another, causing the floating tape to bend in a concave direction. The charged pieces of tape had like charges, which is why they repelled each other in the experiment. I then measured the distance between the center of the two tapes. The purpose of taking this measurement will be explained in a moment. In order to calculate the excess charge, I had to make some assumptions about the pieces of tape. First, I assumed that the charges on both pieces of tape were the same. Students were told to calculate the mass of the tape given that clear tape was 1 gram per meter. Finally, I treated the tapes as point charges. If you look to the right, you can see the free body diagram of the experimental setup, with the electric force pointing upwards and the force of gravity downwards. As stated at the very beginning, the momentum of the tape was zero, so I knew that these two forces were going to sum to zero. Additional values I measured for the purposes of the final calculations can be found in the key, with d being the distance between the tapes, m being the mass of the tape, and the length being the distance the tape covered from the point it left one book stack to the place it attached to the next. Now on to the calculations. First, I solved for the excess charge on the tape. I only had to solve for one piece of tape because I assumed that both tapes had a charge of the same magnitude. I set the equation for the force of gravity equal to the equation for the force of the electric field. I plugged in all of the values I recorded during the experiment into the equation and solved for Q. I got that the magnitude of the charge was 8.3 times 10 to the negative ninth coulombs. I was solving for the magnitude of the charge, so it is a positive value. Next, I calculated the number of electrons on the tape. I did this by taking the overall charge that I calculated in the first problem and dividing by the charge of one electron, 1.6 times 10 to the negative 19th coulombs. I got that the number of electrons was 5.2 times 10 to the 10th. Finally, I solved for the ratio of atoms to electrons. I found the number of atoms by taking the area of the tape and dividing by the area of a singular atom and got 2.4 times 10 to the 17th. Then I solved for the ratio of the number of electrons over the number of atoms using the number of electrons that I found in the previous problem. My final result was that there was a ratio of 2.17 times 10 to the negative 7th. To model the knowledge I gained in this experiment, I wrote a program in GlowScript to model the system computationally. My code is included here. You can see that the user can enter the distance between the two tapes. I entered 0.023 meters, the distance from my experimental run, and I got out the charge that I found in my calculations. You can also see on the right an image similar to that of the free body diagram from a few slides before. If you would like to explore my code in greater depth, you can follow the link at the bottom of the slide. To wrap up, I used what I learned in this experiment to answer a few questions. The first question is, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? To answer, the tapes would have become negatively charged and thus would have repelled a negatively charged pin. The two pieces of tape would still repel one another because like charges repel. Secondly, I looked at the question, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come in contact with your hands or other objects? In order to explain this, you have to look at what happens when charged tapes come in contact with other objects like the hand. The tape is not permanently charged. We create a temporary charge on the tape, so anytime the tape comes in contact with another object, some of the charges transfer. In order to observe a strong interaction between the charged tape and other objects, it is important to handle the tape as little as possible so none of that charge transfers to the hands.